has begun for a buoy or buoy that's become detached from its mooring at sea. The area to be searching is a radius of 30 kilometers from its last known position K. It was here, and for some reason it became detached, and it could be anywhere in this 30-kilometer range. Everybody get it? Come detached from K, and it could be anywhere in this circle. Okay. Search area is divided into 6 equal sectors: A, B, C, D, E, and F. Happy days. Find the angle PKA. Sorry, BKA. B to K to A. BKA. This angle here, everybody see it? Now, here's the deal. How many sectors do you see? Everybody see 6 sectors? What's 360 divided by 6? 60 degrees. Each sector is 60 degrees. Kyoto is divided up into equal sectors. Okay. Now, next thing he wants to do is to find the area of the triangle. See this triangle right here, top of my board? Anybody know what formula to use? Can I use a half base times height? Yay or nay? No, why not? I don't know. I need to know the vertical height here, wouldn't I? I also need to know the base, wouldn't I? All right. Anybody have any alternative suggestions? Half, anybody? A, B, sine, C. Half any two sides and the angle in between. So what's that going to be? A half, anybody? 30 times sine. And what do we get when we log that into the calculator? All right. 30 sine 60. 389.71. Anybody get that last night? Okay, and you use that formula? What's the answer in meters squared, kilometers squared? What do you think? Kilometers squared, isn't it? Right, move on. Okay. Write the area of the triangle KAB as a percentage of the area of the sector. Ooh. Okay. I want the triangle as an area of the sector. Now, the sector is the, if you will, the sector is the full pizza slice. You know what I mean by a pizza slice? The sector is a full pizza slice. Okay. Where'd you find that? Where'd you find the sector formula in your tables? Anybody know? So you go to page 10, 9 or 10, and you find the formula for sector of an area of sector. And it says theta over 360 multiplied by pi r squared. Is that okay? Now, let's fill this in. What does theta stand for, lads? Or this weird symbol here? What's that stand for? The angle. What angle are we using? 60. What about the radius? What's the radius? What's the radius? Anybody at all? The radius is 30 squared. We're going to throw that all into the calculator. Are we expecting a bigger or smaller answer than the triangle we just got? Bigger or smaller than the triangle we got a second ago? See this yellow region here? That's the triangle we got a minute ago. See this full region here? That's the sector we're getting now. So we're expecting the answer to be bigger. Okay? So that's how you know if you got it right or wrong. So we're going to put this all into the calculator. And we got 150 pi, otherwise known as 471.24. All right. Now, we put all that in the calculator and we got 471.24. 471.24 kilometers squared. Have I answered the question properly? Yay or nay? Reread the question. Have I answered it properly? No. It's the area of the triangle, which was, what was the triangle again? 389.71. The area of the triangle divided by the area of the full sector multiplied by 100. And what percentage will that come out as is the real question. 389.71 divided by 471.24. Multiply that by 100. 82.7%. Anybody else get that? Excellent work. Happy days. Use the cosine rule to find the length of AB. Give me a second. KAB. So that's K. That's A, and that's B. That's 60. That's 60. Oh, sorry, 30, isn't it? 30. Radius is 30. 30, 30, and 60 degrees. Okay. Let's find the cosine rule. Anybody know where you're going to find the cosine rule on this thing? Is here anywhere? Oh, page 16. Everybody reading their cosine rule on page 16. What does it say? I love the way some people here are, it's like they're looking at the maths tables for the first time in their life, which is brilliant. All right. So it's a squared equals b squared plus c squared minus 2bc cos a. Everybody cool with that? Okay. Now, what's the point of the question? To find the length of AB. Let's call AB x. Is that cool, you guys? So small a is going to be x squared. Now, anybody tell me what capital A will be? Capital A is the angle you're going to use. You're using 60 because it's opposite the side you're looking for. So that's going to be cos 60. Okay, and what about the other two? 30 squared plus minus 2 times 30 by 30 cos 60. Because it's a length question, just put it all into the calculator and we can figure out what x squared is. Okay, 30 squared plus 30 squared minus 2 bracket 30 cos 60. Got an answer of 900. And then what then? Square root it. Square root of 900. 30. Okay. What does that mean about this triangle? What type of triangle is it? It's equilateral because all three sides are 30. Is that okay with everybody in class? All three sides are 30? Now, I would have known that earlier, and I'll tell you how I would have known. Remember I was told that that was 60? That's a radius and that's a radius, isn't it? So I knew already it was an isosceles triangle, but then there's 120 degrees left over, divided amongst two equal angles. All three of them have to be 60. I would have known that already. They wanted us to do the cosine rule. Okay. Does your answer show about the triangle KAB? It's equilateral. Do not accept my spelling of equilateral. It's probably wrong. I should probably look it up. Next one. All right. Helicopter took part in the search. Helicopter flew from the point F around the perimeter and searched the area. What distance did the helicopter fly? So here's your helicopter. It's going to be the world's crappiest helicopter. Oh God, looks like a boat. My kid can draw it. Oh God, my kid can draw that one. All right, let's get rid of that. Right. This blue line, this blue blob represents the helicopter. What's it going to do? It's going to go around the full circle, isn't it? What's this known as? What page do you find that formula on? Go digging. Huh? All right. Now, The circle looks a lot like a sphere. So look at the English on the right hand side. And please make sure it doesn't say sphere, it says circle. Yes. Yes, you can. Anybody? It's on page 8. And what formula are we using? That's the area. 2 pi r. 2 pi times 30. Plug it all into the calculator. $60 pi, otherwise known as 188 points. Oh, sorry. That's tricky. See the way it's 4956? Is that closer to 188 or 189? It's closer to 188. You know what the weird thing is? If you rounded that off to 188.5, then you'd have to round it up to 189, which would mean you're wrong. Because 49 is closer to 0 than it is to 100. That's basically what you're looking at there, okay? Tricky. Ever kill 188 kilometers? Hey, anybody get it last night? Already then. Now, the helicopter then flew from F to D. Straight from F to D. Does everybody see that? Go straight from F to D. So it flew this path here. Okay. Draw the path of helicopter on the diagram. Done. Happy days. Calculate the angle FDC. Which one's FDC? Oh, let's see what he did then. And then it flew from D to C. So D to C will be this one here. Okay. Question for you. What type of line is F to C? What type of line is it? I think it's the diameter. Would it be the diameter? Yeah. Next question. Are all 3 points on the circle? Are D, C, and F on the circle? What does that mean about this angle here? It is 90 degrees. It's called angle in a semicircle. If one of them's the diameter and all 3 points are on the circle, it's 90 degrees. State the theorem, okay? Angle in a semicircle must be 90 degrees. You could also put your own words on that. You could say if there's 3 points on a circle and two of the points make the diameter, then the angle that faces that diameter has to be 90 degrees. You can use your own words. It doesn't have to be that. Okay, moving on. The helicopter flew at a speed of 80 kilometers an hour. How long did it take to fly from F to D and then on to C? Okay. Do we know the distance F to D? No. Do we know the distance F to C? What's F to C? Anybody? So I'm just going to copy and paste this for myself. Yeah, yeah, you might as well. Okay. What'd you say? Yeah, just give me a second. I just want to copy this onto my other page, so I'm not flicking on the time. Okay. Still on this one. This is a bit of a battle. Everybody sees it? Okay. Can everybody tell me what F to C is? F to C is 60. Everybody cool with that? 60? Okay. Do we know what F to D is? Do we know what F to D is? No. We don't know what F to D is? I have no idea. Does everybody see this red triangle I'm coloring in here? Everybody see this red triangle? Okay. Up. You cool with that? You're going to move that red triangle over here. Everybody see it? Would everybody agree that that's 30? That's also 30. How do we know that? They're both radiuses, aren't they? Can everybody tell me what this angle is in between the two of them? 120. What rule can I use to get f to d? Pythagoras is only useful in a right angle triangle, and this one's not right angle, unfortunately. I can use the cosine rule. So we're going to use the cosine rule again, okay? We've already used it once. So what goes here, lads? What letter? Okay, and the other two sides? 30s, yeah. And then it's exactly the same as we did last time, except one difference. What's the only difference? Cos 120, right? So we're going to go into the calculator with that. Sort of lucky. See, I saved it earlier on. So everything's exactly the same except it's 120 at the end. See, I can just press the up button because I already used it today. I got 2,700. I want us to square root that. Thirty root 3, otherwise known as 51.96. Now, everybody looking? I'm about to do something else now, okay? So that's 51.96 or 30 root 3. I'll call it 30 root 3. Okay. What type of triangle is the green triangle I'm coloring in here? What type of triangle is that? Is it right angled? It's right angled, isn't it? So what does that mean? I'm allowed to use Pythagoras' theorem. And see this side, see DC? Pick a letter we're not using. J. We're going to use Pythagoras' theorem to figure out the length of D to C using Pythagoras' theorem. Ready? 30 root 3 squared equals 60 squared plus J squared. Okay? 2,700 equals, what's 60 squared? Oh, I'm wrong. I'm definitely wrong. 60 is the longest side in the triangle, isn't it? So it's actually 60 squared equals 30 root 3 squared. See the way the 60 is opposite the 90 degrees? Has to be the longest side. That's 3,600. That's, what's this one? That's 2,700. And then after that, what do we get then? 900 equals J squared, and J equals 30 kilometers. Is that okay? So how far did it travel now? How far did it travel? It traveled 30 root 3 from here to here, and then it traveled another 30, didn't it? So it's 30 plus 30 root 3. It traveled 81.96. And how fast was it traveling again? 80 kilometers an hour. And does everybody remember the trick for this? Put it into calculator, 81.96 divided by 80. 1 hour and something. You know this button here? What does that do? 1 hour, 1 minute, and 28 seconds. Just the question asked me to round to the nearest hour or anything like that? Just, or is that okay with you guys? I realized I actually made that harder than I had to. I'll explain now what I could have done differently. Do you remember I did the cosine rule earlier? Okay. I think that was sort of unnecessary, and I'll tell you why. I think it was quite silly. I'll explain why. See the green triangle? That's 90. Actually, no, I was right. Never mind. No, I'm actually all right. Never mind. Thinking too much. Grant. There's a part C to this as well. Yeah. A lifeboat started taking part in the search in a straight in a search part in the search, right? It sailed in a straight line from K until it reached the point X, the midpoint of ED. Calculate KX. Okay. Okay, I'm going to take this diagram here. Okay, I'm just going to cut it. I'm going to bring it over here. And we're going to have a look at what on God's green earth are they talking about. Okay, where does it start from? Would everybody agree the lifeboat is here? Yeah? What's the, and it wants to reach, okay, the midpoint of ED. Where's the midpoint of ED? Everybody see that one there? Okay, calculate K to X. Wants me to calculate this one here. You know what that? Have an idea for that one. Here's my idea. Would everybody agree that this one's 30 from here to here? Why is that 30? What? Radius. Remember we said this whole thing was 30 root 3 earlier, from here to here. What happens if we half that? What do we get? 15 root 3? Okay. Why am I allowed half it? Because it's an isosceles triangle. Because it's an isosceles triangle, I'm allowed half it. And now all I got to do is Pythagoras' theorem, and I'm locked in for that position here to here. Is that all right? I'll use a different letter. I'll use a capital M. If that's okay with you guys. Capital M is the distance k to x. So how do we do that? 30 squared equals what? 15 root 3 squared, yeah? Squared. 900. What's 15 root 3 squared? 675. 900 take away 675. 225. Square root 225. Oh. 15. Yeah, got 15. 15 kilometers it travels. Yo, anybody get that one? Very tough, wasn't it? Yeah. The buoy was located at a point where kx of the lifeboat crossed the path FD of the helicopter. Oof. How far from the buoy was x? Did I not just do that? Oh. Sorry, lads. See the question I just did? See this one I just did here? That's actually the answer to C part 2, not C part 1. I read it wrong. Is that all right? So this is where the buoy was found, where the helicopters line intersect. So all of that there is actually this part here. Sorry, that's my bad. Okay, my bad. I read it as the midpoint of FD, not the midpoint of ED. Okay, so I have to do that again now. Okay, I'm gonna rub this out. Does everybody see ED? Everybody see ED? Yeah. Midpoint. That agreed. Okay. What type of triangle is this? What? So that would be 30, wouldn't it? But I'm going to call that part 15. Why? Yeah, it's half 30. This one here has to be 30 because of the radius, and this length here is what I'm after, isn't it? So 30 squared equals 15 squared plus 900, 225 plus x squared.
675 equals x squared. Square root of 675. 15 root 3, otherwise known as 25.98. Sorry about that.